Imagine a beam of light so powerful it can cut through steel, yet so precise it can perform surgery on the human eye. A beam that travels vast distances without losing focus, staying as sharp as when it was first created. We see lasers in science fiction, but they're not just futuristic fantasy. They're real, and they're all around us. From the barcode scanners in stores to life-saving medical procedures, lasers shape the modern world in ways we rarely stop to think about. But how does a laser actually work? At its core, a laser is a device that produces a special kind of light, unlike the scattered mixed light from the sun or a lamp. The word laser stands for light amplification by stimulated emission of radiation. That might sound complicated, but let's break it down. Regular light consists of many different wavelengths spreading out in all directions. When you turn on a flashlight, its beam quickly fades as it disperses. But laser light is different. It's made up of a single wavelength, meaning it's pure in color and it moves in a perfectly straight line, staying concentrated over long distances. To create this highly organized light, a laser must go through a special process inside a controlled device. It all begins with something called a gain medium, which is a material that amplifies light when energized. This medium can be a gas, a crystal, or even a special liquid. The type of gain medium determines the kind of laser being produced. For example, helium neon gas creates the red laser used in barcode scanners, while a solid crystal called ruby was used in the first laser ever built. The process starts when energy is pumped into the gain medium, usually from an electric current or another strong light source. This energy excites the atoms inside the medium, pushing their electrons into a higher energy state, like a kid bouncing on a trampoline, reaching a peak before coming back down. But just like the kid doesn't stay in the air forever, electrons don't stay excited for long. When they return to their normal state, they release tiny packets of light called photons. This is where the magic happens. If one of these photons passes near another excited atom, it doesn't just trigger the release of a random photon. It triggers one that is identical in wavelength, direction, and phase. This process, called stimulated emission, creates a chain reaction. Now there are two perfectly synchronized photons traveling together. As this process repeats, more and more identical photons are created, building up a powerful and highly focused beam of light. To intensify the light, lasers use a system of mirrors. One mirror at the back of the laser is fully reflective, bouncing all the light back inside the gain medium. The other mirror is only partially reflective, allowing just a small portion of the light to escape. This back and forth bouncing continues, amplifying the light each time until finally a powerful laser beam exits through the partially reflective mirror. This unique type of light has incredible properties. Because all the light waves in a laser beam travel together in perfect alignment, they do not spread out like ordinary light. This means a laser can travel incredible distances without losing intensity. NASA even uses lasers to measure the exact distance between the Earth and the Moon by bouncing a laser beam off reflectors left on the lunar surface. Lasers have revolutionized medicine, allowing doctors to perform surgeries with pinpoint accuracy, correcting vision, and removing tumors without damaging surrounding tissue. In industry, lasers are powerful enough to cut through metal with extreme precision. They're also essential for fiber optic communication, transmitting data across the world at the speed of light. Even the tiny laser inside a DVD player reads information encoded in microscopic grooves on the disc, making movies and music possible with perfect clarity. But the potential of lasers is far from fully explored. Scientists are developing ultra-powerful lasers that could create nuclear fusion, a process that might one day provide limitless clean energy. Researchers are also working on laser propulsion systems which could push spacecraft through space without the need for heavy fuel. Some experts even imagine a future where entire cities are powered by wireless laser energy. Lasers may feel like science fiction, but they are very much a part of our present, and their future possibilities are limitless. From the tiny lasers in everyday electronics to the giant laser systems shaping the future of space travel and energy, this technology continues to push the boundaries of what's possible. Perhaps one day, lasers will take us beyond our own planet, lighting the way to new discoveries across the universe.
Got a question about how something really works? Drop it in the comments and we might cover your topic in our next video.